Welcome to UXL, where you can learn new skills anytime and anywhere. Visit uxl.com to explore our full course selection. This lesson is part of a larger course. Check the video description below for a link to the full course where you can enroll. If you enjoy our content, please like and subscribe. For your convenience, the course cover displayed on your screen provides the complete course title and lesson title. Let's proceed with the lesson. Lesson: Best Practices for Serverless Development. Serverless development has emerged as a transformative approach in cloud computing, particularly within the Amazon Web Services ecosystem. This paradigm eliminates the need for developers to manage underlying infrastructure, allowing them to focus solely on writing code. Despite its myriad advantages, serverless development requires adherence to best practices to fully leverage its potential and avoid common pitfalls. One of the primary best practices in serverless development involves the design and structuring of functions. In AWS, this typically revolves around AWS Lambda. Functions should be single-purpose and fine-grained, adhering to the principle of microservices. This granularity ensures that each function performs a distinct task, which simplifies testing, debugging, and scaling. For instance, a function designed to handle user authentication should not also manage database updates. By isolating responsibilities, developers can enhance the maintainability and clarity of their codebase. Another critical aspect is the efficient management of dependencies. AWS Lambda allows for the inclusion of external libraries through deployment packages. However, these packages should be kept minimal to reduce latency and execution time. Including unnecessary libraries or overly large packages can slow down function execution, impacting performance and cost. Utilizing AWS Lambda layers can mitigate this by sharing common dependencies across multiple functions, ensuring that only essential code is embedded within each function. Performance optimization is a crucial consideration in serverless development. Cold starts, which occur when a function is invoked after being idle, can introduce latency. To mitigate this, developers can employ strategies such as provisioned concurrency, which pre-warms a specified number of instances, ensuring that functions are readily available to handle requests. Additionally, configuring appropriate memory and timeout settings based on the function's requirements can significantly enhance performance. Over-provisioning these settings can lead to unnecessary costs, while under-provisioning can result in timeouts and failures. Security is paramount in serverless applications. The principle of least privilege should guide the configuration of IAM roles and policies, ensuring that functions have only the permissions they require to operate. This minimizes the risk of unauthorized access and potential breaches. Furthermore, sensitive information such as API keys and database credentials should not be hard-coded within functions. Instead, AWS Secrets Manager or AWS Systems Manager parameter store should be utilized to securely store and access sensitive data at runtime. Monitoring and logging are indispensable for maintaining and troubleshooting serverless applications. AWS CloudWatch provides robust capabilities for collecting and analyzing logs and metrics. Developers should configure logging within their functions to capture essential information such as request payloads, responses, and error messages. Additionally, setting up alarms and dashboards can provide real-time insights into application performance and health, enabling proactive identification and resolution of issues. Employing AWS X-Ray can further enhance observability by tracing requests across distributed components, offering a comprehensive view of application behavior and performance. Another best practice is to implement robust testing and continuous integration, continuous deployment pipelines. Given the stateless nature of serverless functions, unit testing is essential to validate individual components. Additionally, integration testing should be conducted to ensure that functions interact correctly with other services and components. Tools such as AWS Code Pipeline and AWS Code Build can automate the deployment process, ensuring that code changes are seamlessly integrated and deployed to production. This reduces the risk of human error and accelerates the development lifecycle. Cost management is a vital consideration in serverless development. While serverless architectures can be cost-effective, Improper design and configuration can lead to unexpected expenses. Functions should be designed to minimize execution time and resource usage, as billing is based on the number of requests and execution duration. Moreover, monitoring usage patterns and setting up budget alarms can help manage costs proactively. Utilizing AWS Cost Explorer can provide detailed insights into spending, enabling developers to optimize their applications for cost efficiency. Scalability is one of the inherent advantages of serverless architectures. AWS Lambda automatically scales functions in response to incoming requests. However, developers must design their applications to handle scale effectively. This includes managing state and data storage appropriately. Stateless functions should externalize state to services such as Amazon DynamoDB or Amazon S3, ensuring that functions remain lightweight and scalable. Additionally, implementing idempotency in functions ensures that repeated executions produce the same result, which is crucial for handling retries and ensuring data consistency. Event-driven design is another key consideration in serverless development. AWS services such as Amazon S3, Amazon SNS, and Amazon SQS can be used to trigger Lambda functions in response to specific events. This decouples components and enhances the responsiveness and flexibility of the application. Designing applications around events allows for seamless integration with other AWS services and external systems, enabling a more modular and scalable architecture. Lastly, documentation and adherence to coding standards are essential best practices. Comprehensive documentation ensures that team members and stakeholders understand the architecture, design decisions, and usage patterns of the serverless application. This includes detailed API documentation, code comments, and architectural diagrams. Adhering to coding standards and best practices, such as naming conventions and code modularity, enhances code readability and maintainability, facilitating collaboration and long-term sustainability of the application. In conclusion, serverless development within the AWS ecosystem offers significant advantages in terms of scalability, cost efficiency, and operational simplicity. However, realizing these benefits requires adherence to best practices in function design, dependency management, performance optimization, security, monitoring, testing, cost management, scalability, event-driven design, and documentation. By following these best practices, developers can build robust, efficient, and secure serverless applications that fully leverage the capabilities of AWS. This concludes the lesson. We trust you found this video informative and engaging. To enroll in the complete course, please use the link provided in the description below. At UXL, we are committed to your learning journey. Each course offers a certificate of completion, online support, and downloadable resource files to enhance your experience. If you found our content valuable, we invite you to like this video and subscribe to our channel. Thank you for joining us, and we look forward to supporting your continued pursuit of knowledge.